So when we put a triangle on a unit circle, that's how we came up with our y and our x values. And we said, well, if we apply that, we know that sine is part of SO in SOHCAHTOA. So it'd be opposite over hypotenuse. In this case, it'd be y over 1, or we're much happier to call it just that y value. It was that second. When I gave you a point, it was the second one. So if I said 1/2 square root of 3 over 2, you'd say it's square root of 3 over 2. I'm going to jump down to cosine. Cosine was adjacent over hypotenuse. Well, adjacent over hypotenuse was x over 1, so it's just going to be x. Oh, yeah. Matthew, if you want, there's sheets over there. Or you can just stare at it and just love life. Let's tackle the reciprocals. Cosecant is the reciprocal of sine. If you know the sine value, you just flip it. If you know your sine value, you just flip it. So if my sine value is 1/2, the cosecant would be 2 over 1, or just 2. So in this case, instead of y, it is going to be 1 over y, or you just flip the fraction. Most of the time, it's just flipping a fraction. To get to our secant, which is the reciprocal of cosine, it's just going to be 1 over x, or you just flip that fraction. Once again, if you go to cosine and it's square root of 3 over 2, and I ask for the secant, you just flip it to 2 over square root of 3. But what are you not allowed to have in the denominator? What was that? 0, 2, or a radical. Yeah, so we're going to have to get radicals out of our denominator. Okay, let's talk about tangent. Tangent is your sine over cosine. It is your sine over cosine. Get rid of this. I don't know why I put that in there. I was going to say something else, but I'm going to get rid of it. So your sine over cosine is just going to be your y value over your x value. And your cotangent is flip that on its head, and it'll be x over y. Most of the time, you're not going to think about this as y's and x's. You're just going to be like, I know what the sine value is, flip it is my cosecant. I know what my cosine value is, flip it, it is my secant value. And in that same vein, you're more than likely just going to memorize your tangent values, so you don't have to do a whole bunch of math to come up with your tangent values. And if you turn the page really quick, you're going to see your new unit circle now has tangent values on it. You will be required to know those tangent values. If you already know your sine, your cosine, your radians, and your degrees, adding tangent onto it isn't that bad because it's just square root of 3, square root of 3 over 3, and 1. And then you have a 0, an undefined, a 0, and an undefined. It really isn't that much, and you could figure it out knowing your sine and cosine. We'll talk about that in just a second. I don't know why the ceiling's shaking. All right, let's go back to all students take calculus. And we're going to add something to that in case you're the person that uses reference angles, which is really, really easy if you use reference angles. If you do not, I'm not going to take points off of, but it's going to take you a little bit longer. So if you're using reference angles, we have all. That just means everything is positive. All are positive. Students, that was sine is positive, and now we're going to attach to that cosecant, because cosecant is just flipping it. If we have a negative sine, we're going to have a negative cosecant because we're just flipping those values. All students take, that's going to be tangent is positive, but that must mean cotangent is also positive. And finally, all students take calculus, that is our cosine is positive, which means my secant is also positive. And we have this super nifty chart that I probably wouldn't want to memorize. This makes it a little easier. Plus, if you just know what all students take calculus, you don't need any of that. All right, let's go ahead and come up with some values. So we are supposed to find the sine of pi over 6. Can someone give me the value of sine of pi over 6, the exact value from your unit circle? Knowing that pi over 6 is that first tick mark. So,
1/2.
1/2. Perfect. Now, does someone want to ride her coattails and tell me what the cosine of pi over 6 is? Now we know it's 1.
Me?
Yep.
Okay, so it's
Sorry.
the square root of 3 over 2.
Square root of 3 over 2. It's always nice when someone finds the first one because you know they come in pairs, right? If it's 1/2, the other one has to be square root of 3 over 2. If it's square root of 2 over 2, then the other one has to be square root of 2 over 2. Let's do tangent. And tangents might require some side work for some people because I didn't put a ton of room to do work in. Remember, tangent is sine over cosine. We already have our sine value. We already have our cosine value. We're just going to put them on top of each other. So we're going to have 1/2 over square root of 3 over 2. And that's going to result in 2 square root of... Where did I mess it? Yeah, no. It'll be 2 over 2 square root of 3. And let's do some side work if you can't do that in your head. I'm just going to open up a new slide to remind you of how fractions work. If you have 1/2, there he is.
Yeah, I thought I had a free.
You didn't.
What?
You didn't.
No, I didn't.
Over square root of 3 over 2. You're going to use something called keep, change, flip. You keep the top fraction, you change your division bar to a multiplication, and you flip that bottom fraction. So once again, keep, change, flip. That people that struggle with this. So I keep the top fraction, which is 1/2, change the division to a multiplication, and we do, no, I didn't flip it. I was like, I did something completely wrong. 2 over square root of 3. Keep, change, flip. Know it, love it, use it. Live it. Yeah, that would have been better. All right, so that's 2 over square root of 3, which is actually equal to 1 over square root of 3. Now, I'm going to put a little note to you guys, because there's a problem here. You can't have a square root in the denominator. So I'm going to put a little note up here. Let's just use that as our example. Note, if you have something like 1 over square root of 3, you can't have a square root in the denominator. So you can't have that. So all you're going to do is you're going to multiply by the radical that you can't have. So in this case, it's square root of 3. So I'm going to multiply the denominator by square root of 3. But I have to keep everything balanced. So we're going to also multiply the numerator by square root of 3. You're actually multiplying by 1, because square root of 3 over square root of 3 is just 1. So it's okay, it keeps everything balanced. And that's just going to equal square root of 3 over square root of 3 times square root of 3 is just 3. It's basically square root of 3 squared. The squared cancels out the square root. Is that jogging some memories on how to do that? Okay. Because I'm going to be mostly glazing over some of that stuff here. So if I multiply the top and bottom by square root of 3, we are going to end up with, this is just going to equal square root of 3 over 3. Boom. Everything else is just flipping those. Everything else is just flipping those. So our cotangent is flip your tangent value. Right now my tangent value is square root of 3 over 3. We take the reciprocal of it, so we're looking at 3 over square root of 3. Once again, I can't have a radical in the denominator, so we're just going to do that, which is going to equal 3 square root of 3 over 3. Your 3's are going to cancel out, and you'll just be left with square root of 3. Secant goes with cosine. Find your cosine value and flip it. All right, once again, secant goes with cosine. You find your cosine value and you flip it. Our cosine value right now is square root of 3 over 2. So when I take the reciprocal of it, we are going to have 2 over square root of 3. We have to get rid of the radical, so we're going to multiply the top and bottom by square root of 3. Bless you. And we'll have 2 square root of 3 over 3. You cannot simplify it, so we're just going to put that there.
For the cotangent, why didn't you simplify it to square root of, oh, you did.
Exactly, because I did. I don't know what you're going to say, but I did it, maybe.
Yeah, no, I didn't realize that.
Okay, I have the right value there. That's all I know.
Yeah, no.
All right, cosecant. Cosecant goes with sine, so we just take the reciprocal of 1 over 2, which is 2 over 1. But it's pretty ridiculous to put 2 over 1, so it's just the dose. The dose. All right, what is the sine of pi over 4? Mary? Yep, perfect. Radical 2 over 2. I will take the cosine one, because that's easy. If it's square root of 2 over 2, then the pair is square root of 2 over 2. Our tangent is our sine value over our cosine value. Our sine value is square root of 2 over 2. Our cosine value is square root of 2 over 2. Work smarter, not harder. I could do the keep, change, flip on this, but I have the same thing on top as the bottom, which means it must equal 1. It must equal 1. So this value is just 1. Cotangent, 1 over 1. Take the reciprocal. You now have upside down 1 over 1, which is still 1. Are there not sheets for you? Is that why you're not?
I didn't know.
Oh, you should have said something. I can.
What should I grab some?
We should have had them, but I forgot that we had an extra person, and it didn't get printed out. Let me print some out real quick. You should have said something. That's okay. We're not too far. You should be able to copy all that down. As long as you're following around. It makes sense, though, right?
I think so.
I think so. There you go. I mean, why not?
That looks like pants. Oh, so it was the one for pants. The other side would be the other way. No. What? Oh, you had it. Yeah. What is that? It's a gang sign.
Quit throwing gang signs. Who's throwing gang signs?
Nothing.
Quit throwing gang signs. See you guys later.
What?
What? Oh, he's gang. Yeah, I just realized. I thought we
He's
yanked.
done his gang affiliated student.
Yeah, I don't know why you didn't have to grab it. That's
I would have gone. Yeah, you've been gone for like 10 minutes then. Oh, Matt.
What life?
Yeah, why did you all of a sudden
Thought I
think
had a free.
that you had this class?
Because it's either this class or free last Matt, or not Matt.
I do that all the time, Ross.
How did you realize
Just be honest
it?
here.
How did you realize it was
Yeah, I
now?
was doing for homework, and then you almost do. I'm like, oh yeah, I'm supposed to read.
Don't say anything nice for you. You guys are still here?
No.
Okay.
I wish I wasn't.
Hey.
I'm kidding, not
Hey.
because of you.
No, I'm just kidding.
I'm actually not here.
All right. Oh, that awesome thing's on there. Cool. There we go. Life continues. All right, we were at cotangent. Now let's go to secant. Secant is just take your cosine and flip it. So take your cosine value and flip it. Our cosine value is square root of 2 over 2, so we're going to flip it and go 2 over square root of 2. Need to get rid of that reciprocal, or not the reciprocal, but the radical. And we are going to have 2 square root of 2 over 2, which is just square root of 2. Well, cosecant is flip sine. Sine is square root of 2 over 2. Flip it, it's 2 over square root of 2. We already did all that work. This will also be square root of 2.
Wait, why? You said like 2 like 6 times.
I did.
I don't. I do not follow that.
Okay. Cosecant, I have to flip my sine value. My sine value is square root of 2 over 2, so it is a lot of 2's happening. So flipping it would be 2 over square root of 2. But we already simplified all those 2's, and it came out to 2 square root of 2 over 2, which is another 2, and then we have a square root of 2, and the whole answer is a square root of 2.
Yeah.
You watch out on problem number 2 on the test. That's going to have lots of 2's. I should make sure problem number 2 has this in it. And then someone will get it. I know, they heard my awesome 2 jokes. Does that make sense, though? All humor aside.
This is too funny.
And you're too much. All right, sine of pi over 3. Who's got sine of pi over 3 for me? Bree. Yep. Which means cosine is 1/2. Which means tangent, which is sine over cosine, would be square root of 3 over 2 over 1/2. What I'm picturing is keep, change, flip. I keep the square root of 3 over 2. I change it to multiplication, and I'm multiplying by 2 over 1, which will result in 2 square root of 3 over 2. If you need extra space, you can probably do it down here too. All right, 2's cancel out. You're just left with square root of 3. These are now all of our new tangent values minus 0 and undefined. Square root of 3 over 3, 1, and square root of 3. Those are the only new values you need to know. Cotangent is go ahead and flip it. Well, square root of 3, the reciprocal would be bless you, and would also be 1 over square root of 3. Which if I multiply the bottom and top by square root of 3, I'm going to result in square root of 3 over 3, which doesn't need any more simplifying. Secant is flip your cosine. Cosine right now is 1/2, so it'd be 2 over 1, or just 2. Cosecant would be flip the sine value, which was 2 over square root of 3. Multiply the top and bottom by square root of 3. Come up with 2 square root of 3 over 3. Whew. Mary. Uh-huh. Because all those values stay the same, right? Yeah. You just got to know they're flipped. Okay. Yep. It kind of works the same way as sine and cosine. If you know one pair works the other, same with the secant and the cosecant. All right. I am not going to do all of these with you. You're going to do them. I'll put it back up. I'll put it back up if that makes you happier. Because you do have a unit circle right in your hand. I'm looking at it right now as you're pulling it out. It's crazy. So you're going to do this on your own. So I'm going to skip it. Good. Do it in your head. I would practice doing stuff in my head before I do this stuff. We're going to do example 2 together, though, first. Because that is using your oh, that works better than my noggin. All right. We'll use our calculator. We'll use a calculator. I was going to use my head and do all the problems for you, but he wanted to use his calculator, so we're going to do. All right, we're going to use our calculator. So let's take our calculators out. Let's see if mine's out. My Wabbit is out. It says Wabbit. EMU. I thought I just lost it. I finally lost it. Okay, so we're going to turn on our calculators. I did it. And then we're going to look at what it says. It says secant of pi over 12. In my head, I'm saying, okay, pi is in radians. So we need to put our calculator in radians. So I go to my mode button, and I make sure I'm in radian mode. The next thing I'm going to do is exit out of there. And then I'm going to find my secant button. So let's just all locate our secant button. It just says SEC, yeah. No, that's sine inverse.
Where is it?
There isn't one. Trick. It's not on there. It's a trick. We're punny today. All right. There is no secant button because whoever made your calculator decided you're smarter than that and they don't need to dedicate a button to that. They decided that you should recognize that secant is the reciprocal of cosine. So you need to be able to recognize that this is actually 1 over secant of pi over 12. Not a secant. Oof, I had too many secants in my head. Cosine. 1 over secant. Oh, we still don't have a secant button. It is 1 over cosine of pi over 12. That we can plug into our calculator. That we can now plug into our calculator. And we have 1 divided by cosine of pi over 12. That looks like 11, 12.
1.035.
Yeah. What's the direction say? What do we have to round it to?
1.0353.
Ooh, 4 decimal places. Some of us need to look at directions to see what it rounds to. Because there was one particular question on the test that said round specifically to the thousandth place. I didn't take any points off this time. But if I don't tell you where to round, you kind of pick where you're going to round. If I tell you where to round, you better round to the decimal place I tell you to, otherwise you lose a half point. What was that? What about them?
I apologize for my drawing.
I don't know.
Was that negative?
Anywho, let's go ahead and do the next 2 right off the bat. Actually, I'm going to skip to C. I'm going to skip to problem C because I don't, that sounds terrible. Because I noticed, I was going to say, cause I'm going to skip to C because I see. I'm going to skip till C because I noticed that it's still in radians. So why go back and forth on your calculator? Why not, if I have a calculator section, do all the ones that are in radians first, and then do all the ones that are in degrees. That one's in radians because there is no degree. Once again, I have to recognize that cotangent isn't a button on my calculator, so I have to plug in 1 over tangent of negative 12.4. Before I continue, this was the easiest problem that people missed on this test. Because it literally is using your calculator. You just have to recognize this 1 over tangent. It was easily one of the most missed questions last year, and it's not hard to do. It's just plugging numbers into your calculator, but you have to recognize that it is 1 over tangent. All right, which should come out to 5.955 uno. Is that el correcto? Bless you.
Wait, I got a negative.
You're wrong. I'm right. Did you make sure you typed in 1 over tangent of negative 12.4? Found the mistake. All right, then we're going to find 1 over sine of 123 degrees, which should come out to about, as long as you put your calculator in degree mode and didn't forget to do that, 1.1924. But your calculator has to be in degree mode.
Why?
Otherwise, you're not going to get the right answer. Because you need to tell your calculator, hey, you're about to get some degrees. Or hey, check out these radians. All right, questions on any one of those 3? All right, we just have a couple more things, and then I'm going to cut you loose. These are all of your tangent values. You need to know them. You need to know tangent values. So if I give you another unit circle quiz, you will have to put tangent values on it now. The particular one I want to point out right now is, see this undefined? That is undefined because tangent of pi over 2 is sine over cosine, which should be 1 over 0, which was brought up that you can't do that. That is undefined. But I also want to put on there cotangent of pi over 2 would be 0 over 1, which equals 0. And why I mention that is because tangent is undefined. What we normally do is we just flip it to find our cotangent. It's hard to flip undefined. You have to know if tangent's undefined, cotangent's 0. If tangent is 0, cotangent's undefined. All right, once again, if tangent is undefined, cotangent equals 0. If tangent is 0, your cotangent is undefined. They're opposites of each other. So if one is 0, the other one's undefined. It's hard to do because you can't really flip things. You can't just look quickly and go, oh, flip the 0, reciprocal, it's still 0. No, your cotangent there would be undefined. All right, any questions for me? All right, then the rest of this is due tomorrow. There will be no homework over the weekend, so I'm just going to assign another homework today. No, I'm just kidding. This is it. If you work diligently in this, you'll get this whole thing. I'm going to take a picture of it. So the answer key will be right up there. The rest, as long as you are diligent working on it, you'll get a ton of it done in class. All right, I'll cut you loose.